So what I want to talk about today is something called the remainder theorem. So let's look back at long division real quick. Here's an example. I'm just going to let it run quickly. This is the process to get through it all. If you need to refresh your memory on that, please do so. But now that we have that, I just want to look at the remainder. So we have the answer is x squared plus 3x minus 1 with a remainder 4. And my question is, can we find that remainder faster? So if we consider f of x, so a function, to be x cubed plus x squared minus 7x plus 6, and we want to divide that function by x minus 2, which is what we did over here. Then calculate for me what f at 2 is. Do it. Do it now. Did you get 4? That seems to be the remainder. So it looks like if we take a polynomial and we divide it by x minus a, then the remainder seems to be the same as p at a. Now, notice that x minus a, so in our last example we had x minus 2, and I just had to plug in 2. So I had to do p at 2. And that gave me the remainder. So that's interesting. But what about the example yesterday where we did long division? So that was the example from yesterday. And if we look at f at negative 1, right? Because you see how here I have 2x plus 1. So it looks like I should plug in negative 1. So if I do f at negative 1, we get negative 8. And that's not the remainder. But maybe, just maybe, this 2 has something to do with it as well. So instead of plugging in negative 1, we can try to plug in negative 1 over 2 and see if that works. And if you do that, try it, we get that f at negative half is actually 1. And that was the remainder. So that's pretty interesting. So what we see happening is something called the remainder theorem. And what it says is that if we want to take a polynomial and divide it by a linear, so ax minus b, it always has the remainder that we can calculate by calculating p of b over a. So for example, if we want to divide something by 3x minus 2, all I would have to do is calculate p at 2 over 3. So let's see that in action. What's the remainder if I want to do 2x cubed minus 3x plus 1 divided by 2x minus 3? Well, all I have to do is calculate p at 3 over 2, and I'll just plug that into my polynomial here. So that 3 over 2 comes from right here. Remember, it was ax minus b, and I took b over a. So this is b, and this is a. I plugged in b over a, I got this expression, And finally, that gives me the answer 1. So the remainder would be 1. So now, if I just want to know the remainder, we can bypass long division. And we'll see why that's important in a day or so.